The strategic balance in the East China Sea is increasingly defined by the capabilities of rapid deployment forces, particularly regarding the defense and potential recapture of remote island territories. Within this maritime theater, a direct technical comparison between the primary amphibious assault vehicles of Japan and China reveals a complex interplay of engineering philosophies, doctrinal differences, and geographical realities. The Japanese Ground Self-Defense Force relies on the American-designed AAV7A1 RAM RS, a platform with a lineage dating back decades, while the People's Liberation Army Navy Marine Corps operates the ZBD-05, a vehicle frequently cited as the fastest amphibious armor in the world. An objective analysis of these two platforms demands a move beyond simple top-speed comparisons to understand the specific tactical requirements of the Nansei Shoto island chain. The ZBD-05, also known in its export variant as the VN-18, represents a singular focus on hydrodynamic performance. Chinese engineers designed this vehicle to overcome the traditional vulnerability of amphibious assaults, which is the slow transit time from ship to shore where vehicles remain exposed to defensive fire. To achieve high water speeds, the ZBD-05 utilizes a planing hull design. When the vehicle activates its transom plate and bow flap, it effectively lifts the hull out of the water, reducing drag significantly. Powered by a high-performance engine that can switch modes for marine operation, the ZBD-05 drives powerful water jets to achieve speeds between 25 and 28 kilometers per hour. This capability allows Chinese forces to launch assaults from over the horizon, keeping their transport ships out of range of direct fire, while closing the distance to the beach rapidly. In terms of firepower, the ZBD-05 also presents a formidable profile. It is equipped with a 30mm automatic cannon and a rail for HJ-73 anti-tank guided missiles, providing it with the capacity to engage both light fortifications and armored targets upon landing. This configuration reflects an offensive doctrine where the vehicle is expected to fight its way onto a hostile beach and secure a foothold through shock and intensity. The combination of speed and heavy armament makes the ZBD-05 a significant threat in any scenario involving a mass landing operation. In stark contrast, the AAV7A1 RAM RS, operated by the Japanese Amphibious Rapid Deployment Brigade, appears technically modest on paper. Its water speed tops out at approximately 13 kilometers per hour, roughly half the speed of its Chinese counterpart. Its displacement hull pushes through the water rather than gliding over it, creating a larger wake and a slower approach profile. The primary armament typically consists of a 12.7mm heavy machine gun and a 40mm automatic grenade launcher. Critics often point to these specifications to argue that the Japan Ground Self-Defense Force operates an obsolete platform in the face of modern threats. However, such a critique overlooks the specific geographic and operational constraints of the Japanese archipelago. The defense of the Nansei Shoto involves operating around coral reefs, jagged volcanic rock, and steep littoral gradients. The ZBD-05 achieves its record-breaking speed through a complex system of hydraulic flaps and water jets. While effective in open water or on sandy beaches, these mechanisms are susceptible to damage from coral heads and underwater obstacles. A water jet intake clogged by seaweed or debris, or a planing flap damaged by a reef impact, renders the high-speed vehicle immobile or dangerously unstable. The AAV7 relies on a fully tracked propulsion system for both land and water movement, although it also utilizes water jets for steering and supplemental thrust in the RAM RS variant. The track design is inherently robust. It can grind over sharp coral and gain traction on rocky, uneven shorelines where a specialized planing hull might struggle or sustain hull breaches. For the Japanese Ground Self-Defense Force, reliability in the specific terrain of the Ryukyu Islands takes precedence over raw speed in open water. The ability of the AAV7 to carry 21 combat-equipped troops, compared to the roughly 8 to 10 infantrymen carried by the ZBD-05, also offers a logistical advantage, allowing Japan to land a larger concentration of force with fewer vehicles. Furthermore, the tactical employment of these vehicles differs fundamentally. The Chinese doctrine envisions the ZBD-05 acting as a primary assault wave, using its own speed to cross the danger zone. The Japanese doctrine, conversely, integrates the AAV-7 into a broader system of transport. The AAV-7s are often deployed from landing craft air cushions, or LCACs, which transport the armored vehicles at speeds exceeding 70 kilometers per hour to the very edge of the surf zone. In this operational concept, the AAV-7 only travels under its own power for the final few hundred meters. This renders the speed disadvantage of the vehicle less critical, as the LCAC provides the over-the-horizon capability that the ZBD-05 attempts to achieve with its own engine. Protection levels also diverge between the two designs. To achieve buoyancy and planing capability, the ZBD-05 utilizes an aluminum alloy hull that prioritizes weight reduction. While exact data remains classified, analysts suggest that the sacrifice for speed is a reduction in armor thickness, potentially making it vulnerable to heavy machine gun fire or shell splinters. The Japanese AAV7, specifically the upgraded variant with enhanced applique armor kits, creates a distinct visual profile with its corrugated armor panels. This configuration is designed to withstand small arms fire and artillery fragments more effectively, prioritizing the survival of the large infantry squad inside. It is also necessary to address the future trajectory of Japanese amphibious capabilities. Recognizing the age of the AAV7 platform, Mitsubishi Heavy Industries has been engaged in the development of a next-generation amphibious vehicle. This domestic project aims to bridge the gap between reliability and performance, seeking to create a vehicle with an improved water speed of roughly 20 to 25 kilometers per hour without sacrificing the durability required for coral reef operations. The push for a domestic solution reflects the broader Japanese strategy of maintaining an indigenous defense industrial base capable of producing equipment tailored specifically to national geography, rather than relying solely on foreign procurement. Ultimately, the comparison between the AAV7 and the ZBD-05 is not merely a race between two machines, but a clash of two different strategic necessities. The Chinese vehicle is a spearhead designed for projection and offensive speed, accepting trade-offs in protection and complexity to achieve rapid shore arrival. The Japanese vehicle is a shield and a transport, designed for resilience, capacity, and the specific ability to navigate the treacherous shorelines of the southern islands. While the ZBD-05 holds a clear kinetic advantage in a vacuum, the effectiveness of the AAV7 within the combined arms framework of the Japan Self-Defense Force remains potent. The outcome of any potential engagement would likely depend less on the top speed of the vehicles and more on the supporting assets, including air superiority and naval logistics, that each side can bring to the contest.